Assalamu alaikum everyone. How are you? Here is Muhammad Salman, and I have experience in teaching IGCSE Physics and A-level Physics. Okay, I also have experience in teaching AP Physics, but my video is basically why I started making video on the topics like why I started my YouTube channel, basically, you can say, is because most of my students they ask me to start and explain topics on YouTube and upload the lessons. So this is my first lesson, and why I started from momentum, not from the very first topic. The reason is I left some of my students in a school who actually completed their year 10, and they did some topics like you can see they did about 50% of their course, and now in year 11 you can see they will be starting from momentum. So the first topic I'm doing momentum, and then I'll also be doing other topics, but I would need your feedback in the comment section so I can improve. And to be honest, I'm not very familiar with these devices mostly. I used to take online classes, but recording the video and then uploading it, I'm not very expert in these things. So I will need your feedback regarding this, and also regarding the topic that you understand or not. Okay, so let's start quickly from the momentum. So momentum is basically the topic where usually the students they struggle mostly when they solve problems and they solve questions, exam style questions. Okay, the topic is very small, but variety of questions are possible on this. That's why it is considered as one of the challenging topics. So mostly we don't do it in year 10. We usually do, many schools do this to the students in year 11 because their we can see their understanding level then improves, and then that is different in year 11. So then we start from momentum mostly in year 11. Okay, let's do this. Okay, this is from the syllabus. I've taken a screenshot. You can see these four learning objectives we have to cover about the momentum. The very first one is we need to know the definition of momentum as this. We need to know the definition of impulse. We need to know the relation between impulse and momentum. We need to know the principle of conservation of momentum. We need to apply it. We need to solve problems on it. And we need to also know that change in momentum with time is equal to the resultant force. So these are the four LOs we have to cover. So let's start from the very first one, the momentum. But if you do this in your class, so mostly the teachers, they start the lesson from this, that they actually do they show you two objects, one smaller object and one bigger object, and they ask you to tell us which object will be difficult to solve. Okay, so that is the very first question from the teacher, right? Okay, so when they ask you to, so mostly the students say that, for example, these are the two objects. In your course, they can show you a car and a bike. Okay, so they will ask you, let's say this is object A and this is object B, and I'm asking you, they are on the same inclined plane. I mean, the same angle inclined plane is there, and they both are sliding on this inclined plane. Okay, so which one will be difficult to solve? Okay, B has more mass, A has more mass, and B has less mass. So you will definitely see A. Why A? You will see because A will have more motion. Okay. Okay. And B will have less motion as compared to the A. Okay. The reason is what? The reason is for that it has more mass. Okay. And it is also the reason that it will have more inertia. More mass and more inertia, Newton's first law. Okay. So basically we are doing it now in term of momentum. So you will say you are basically looking to the motion, actually which one will have more motion. So you see A will have more motion. So momentum is basically the thing that measure, the general definition is the measure of quantity of motion of a moving object, right? Okay, the measure of quantity of motion is basically the momentum. So we were basically comparing the momentum of A with the B. We see A will have more motion, A will be difficult to stop because it will have more motion. And that's, and this way, it will have more momentum, right? Okay, that is done. So this is the general definition. Then mathematical definition that is written here, because in physics, we don't say the things generally, we measure them. So how to measure this momentum then? So there is an equation, a mathematical equation which says mass times velocity is basically the momentum, right? This is the momentum actually. How to measure it? You should take the mass of object and then multiply it with its velocity, so you will get the momentum, right? This is so simple. Now come to the unit of the momentum. So basically we use two units and we use the SI units. So if you are deriving the units of mass, you already know the SI unit is kg. The velocity unit is meter per second. So it becomes kg meter per second. But you will also see another unit that is Newton second. So this can also be used as the unit of momentum. Okay, this is not in your syllabus to know that how Newton second, but you can also learn it in this way. If you know that force is equals to mass times acceleration, so you know that basically this is giving us Newton. So you can say kg meter per second squared is basically the unit of the base unit of Newton. Okay, so if I take this one and I write it here, so it will be kg meter per second squared, and then I multiply it with the s, so it will give me Newton second. Okay, if you just see here, this square is in division, so it can be the two can be cancelled out with the s. So the remaining is basically kg meter per second. So kg meter per second is equals to Newton second as well. Okay, now these are the two units. Okay, I will go simple. If you have any question, you can ask me in the comment. Then I do not want to complicate it because there is no such things that I go in too much deep, and you know them. The other things which are actually important, they are coming. Okay, so here is the definition we learned. This is the classical definition, like you can say simple general definition, you can say. This is the one mathematical definition in exam. If it comes define momentum, you say the product of mass and velocity is basically momentum. And you can write this equation. It is also acceptable. Okay, the second one, okay, before come to the second one, I want to tell you about the scalar and vector quantity. One thing keep in mind, momentum is basically, it's a vector quantity. Okay, it's a vector quantity, and generally you also know must know that vector quantity, how we can get vector quantity. If two quantities multiply, let's say scalar times vector, so it will give you a vector quantity. If you multiply scalar times scalar, okay, it will give you a scalar quantity. Okay, and the last one, vector times vector, if you multiply, like there are two vector quantities, so it will also give you a scalar quantity, right? Okay, so this is in the case of if you know work done, so the work done is equals to force times displacement, right? So both of them are vectors. So the product, which is basically the work done, is a scalar quantity. Okay, here I was talking about this one. So here is mass and here is velocity. So velocity is basically a vector quantity and mass is a scalar quantity. So scalar times vector is giving you a vector quantity. So momentum is a vector quantity and it will have magnitude plus direction. Okay, so you can then describe it. So this was simple about the momentum. Okay, simple questions can come on this as well. The examiner can give you simple the mass of an object. Okay, let's say 60 kg is the mass. Okay. And he can also give you the velocity. The velocity is, let's say, 10 meters per second. And they can ask you what will be the momentum. So simple, you will multiply them. Okay. But the proper way, I have told students to first write the equation. So if it is in the exam, it will have 1 mark. If it is in the theory question, structure question, and then put the values 60 times 10, so you will get 600 kg meter per second. If the question has 2 marks, 1 mark on the equation and one mark on the substitution and the answer. Okay. Now, sometimes these type of questions can also have 3 marks, but this will not come 3 mark question. This is simple, but sometimes if a question is and it has 3 marks, then divide the 3 marks, one on the equation, one on the substitution, and one on the answer with the unit. Okay. There is no zero point 0.5 marks. Let's say if it has 1 mark and the unit is missing, so the examiner will not give you any marks. So you will get 2 marks out of 3 then. Okay, this is so clear. Now I'm moving to some other questions, some other concepts, okay, regarding the momentum. Try to understand that. Okay. Now let's come to the concept, which is very important to understand. For example, you have a wall, okay, there is a wall, and a ball is coming towards this wall, okay, with let's say its mass is uh, going to be 60 kg, okay, and it is actually going to hit the wall with the velocity of 2 meters per second. Okay. Now, what will be the momentum of this? Try to understand that. So you will see momentum P is equals to 60. I'm not putting the equation again because to save time, times 2, okay, is going to be 120 kg per second. Okay. Okay, this is a very big momentum. A ball is 60 kg, it means it is made of steel or any other heavy metal or something, and it's very heavy. That's why its momentum is very big momentum. Okay, big value of momentum is there. Okay, now the question is, uh, just a second. Okay, so this was so simple, right? The concept is what? Let's say this ball has hit this wall and now it is going to go in this direction after hitting this wall. Okay, the momentum is, let's say, the same. Sorry, the velocity is the same. The mass is also the same. It does not change. Okay, now what will be its momentum? So as we mentioned that momentum is a vector quantity, right? You are going to choose a direction and you are going to give it a sign. So you, let's say this ball was going to the right. So you will say to the right, it is positive. Okay, the velocity is positive. And if this ball go to the left, it will be negative, right? So now the same thing you will do, but the velocity will become negative. Okay, the momentum will not change. The momentum is the same. Okay, because momentum is always conserved. Okay, so you will write P equals to 60 times minus 2. It will be minus 120 kg meter per second. Sign convention must be understood. You must know that the one direction will be positive, so another direction of the same ball, if it is going in another direction, will be negative. Or sometime there will be two balls. Okay, we will be making it more clear than in the conservation of principle of conservation of momentum. But let's say one ball is going this way, so its velocity is positive, another is going this way, so its velocity is negative, right? Okay, now this concept is clear, right? Now, what more we need to know about the momentum? I think the simple momentum is now done. It's clear, right? Now I'm going toward the impulse, okay? But before I go, I will need to go towards the a learning objective, that is define impulse, okay, first, and then show the relation of the impulse and the change in momentum. So let's come to the impulse now. Okay, what is impulse? Okay. Now, impulse is basically, if I compare it with the momentum, then you will better understand. I think so. If I compare it with the momentum, so impulse is basically, if I define both, let's say, so momentum tells us how much motion an object has, while impulse tells us, no need to write this, but it's my first videos who I'm just writing everything for you, while impulse tells us how much its momentum changes. Okay, how much its momentum changes. Okay, I have already shown you the relation between impulse and momentum. So I can write here impulse is equals to change in momentum. I'm coming to this the simple definition of impulse, but before, better to compare them so you will better understand. Okay, change in momentum. It means that, for example, an object has its final momentum 50 Newton second, and its initial momentum was 30 Newton second. Okay, so its change in momentum will be 50 minus 30, so 20. So 20 Newton second is the change in momentum, right? So impulse is basically equals to impulse basically measure how much change has happened in the momentum. Okay, this is the relation of impulse and momentum. Okay, okay, now let's come, I'm coming back to this because this is very important, but let's do impulse individually now. Okay, impulse is here, you can actually take it as effect of force acting for some time. Okay, so you can see effect of force acting for some time. Okay. So mathematically, we write it like this. There is no symbol used in IGCSE, so we write it like this. But in most of the other curriculums, they use the one that is J mostly for the impulse. But we will write it as impulse. Force time time is basically the impulse. Okay. So if more force is there, and more time is there, an object will have more impulse. Means effect of force acting for some time, time or for any time will be more than if you increase the force or you increase the time. Okay, this is simple impulse. Okay, and I also compared the impulse relation with the momentum to you, that what is the relation of momentum and impulse. So impulse is basically equals to change in momentum, right? Okay, just a second, have something here. Okay, so this is done. This is impulse individually we did, and its unit is Newton second, and its unit can also be the same as momentum. Okay, so both are the units of impulse, and you simply take the force times the time, and you get the momentum, the impulse, right? Okay, now most of the time the students get confused in these things. Let's say I saw a question I remember in the past paper. There was a question they asked the students that find the impulse, and the force was given, let's say 100 Newton, and times with the for how much time it was actually applied. It was, let's say, 2 seconds. Okay, 100 times 2 is, let's say, 200 Newton second. And this impulse was for a specific object, let's say object A. And then in the second part of the question, this is A, this is B. They also give the mass of the object, but the velocity of the object was not there, right? So let's say mass of the object is also given. Let's say that is 20 kg. Okay. Now, when it comes to the student, they are actually calculating the momentum. So then they see, oh, momentum was equals to mass and velocity, right? Mass is there, but velocity is not there. How to find? As I told you, momentum is equals to change in momentum, basically. Okay. So change in momentum here and momentum are the same. Like this is the change in momentum that has happened. Okay, so this impulse will cause the change in momentum and the same change will happen. So momentum is basically also equals to impulse. Like if there is no change written, even you can consider it momentum is equals to impulse, so you will not be confused. So the answer was simple. Momentum was also the same. And the other clue was this, that it was having only one mark. There was no solution needed. So you must know if it has one mark, okay, and this question has, let's say, 2 marks, and this has 1 mark, it means the answer is somewhere written clearly and no calculation is needed. Because if calculation is needed, it would not have 1 mark. That is so simple, right? Okay. Now this is done. Now there is one more relation that is derived from the Newton's second law. As you know that F is equals to mass times acceleration. I'm basically now doing this one relation, okay, to make you understand. This one is going to be done in the next video because it is a little bigger concept. You need to understand many things in this, and then I'll be solving past papers as well. Okay. Now, so this relation you already know, Newton's second law, F is equals to ma. We can also write it in this way that mass times acceleration, you already know that final velocity minus initial velocity divided by change in time. Okay. Now, if I multiply this mass with this equation, so it will become mv minus mu divided by delta t. Okay. Now, if we further go ahead, so this mass mv minus mu is basically change in momentum. This is basically change in momentum. So I can replace it with delta p divided by delta t and F is equal to this. So resultant force can also be calculated by using this equation or the above equation, which is F equals to ma. So sometime momentum is given and change in time is given, change in momentum and change in time is given, and they ask you in the exam that find the resultant force. So you must not go for the mass and acceleration. You can have these two values, you can put them. Or sometimes it is not directly given, but it is given in this form. Like you will have the mass, you will have the final and initial velocity. Just use this equation first, find the change in momentum, and then divided by the change in time will also be there. You will get the resultant force, right? Okay. What the concept is, sometimes the reasoning question comes, like for example, they can ask you that if you see a cricket ball player, a cricket player, cricket, right? So when they catch the ball, they actually drag their hands back. Like for example, the ball is here, their hands are here, so they drag their hands till here. Okay, what's the reason? Okay, so try to understand this concept. F is equals to delta P divided by delta T. So this force has its effect, right? If you want to reduce its effect, okay, you need to increase the time of impact. Let's say you catch the ball and you keep dragging your hands backward, okay, like till here. So the ball will be with your in contact with your hands for a long time. So basically, you increase the time of impact with your hands, okay? The time of contact with your hands. So as the time of contact increases, the effective force decreases. So the players actually they do not get hurt. Understand? Okay, there is another, if someone is from Pakistan, in Pakistan mostly the students, they're in the past they used to be beaten by a stick by the teachers. So some of the students they used to drag their hands backward. Okay, so they were very clever because they already knew the momentum and the impulse. So for example, if you drag your hand backward, like or you lower your hand while the teacher or someone is beating you here on the hand. So basically, you increase the time of contact. The time of contact increases, so this person was hurt but little, right? So this is the concept. So sometimes they ask you this, and sometimes they also ask you, for example, there is airbag in the car. Okay, let's say this is the car and the passenger is sitting here and there is an airbag, right? So now if the airbag is not there, the passenger got an accident, so he will hit this car, this front, you can say that is the bonnet, I think, switchboard. Yeah. So when he actually hit the switchboard directly, he will be hurt. Okay. But if there is an airbag, so his face will come on the airbag and the airbag will be pressed for some time. So look, the time of contact increases, so he will be hurt, but a little, right? So this is one of the concept here you must understand, right? Oh, let me check what is remaining in this concept. Nothing. Inshallah, we will be doing questions on this. Yeah, you can also change this into this equation, if t equals to change in moments. So this is basically the same relation as impulse is equals to change in momentum, right? Change in momentum. Okay, so please take write these all equations which we have done. These all equations will be used to solve different questions. Okay, and inshallah, exam style questions will be shared with you in after we do the principle of momentum. Okay, this was my very first video. Please give me a feedback. Here is a question. Yeah, sorry, I already put it here. Okay, here is a train. You can see the total mass of the train and its passenger is this. The train is traveling at a speed of this, and the driver applies the brakes, and the train takes 80 seconds to slow down to a speed of this. Now, calculate the impulse applied to the train. Okay, as you know that the impulse is equals to force times t. Check, do you have the force and the time? Okay, the time is there, but the force is there? No, there is no force. Okay, now it can also be done by using other equations, like you first go to find the force by the Newton's second law, you put the mass, its acceleration, but it will take a lot of time. Okay, so you need to be very smart. Okay, you need to know the relation between the impulse and momentum. So we will go for this. Impulse is equals to change in momentum. Now we will evaluate this. Impulse is equals to change in momentum is basically mv minus mu, and here is the impulse. So the impulse is already this. Okay. Now we have the mass, we have the final velocity, and we have the initial velocity. So this equation is going to help us. So let's say you write this impulse is equals to change in momentum in this form or in this form, you will get 1 mark from the examiner, right? Now, put the values. Mass is already there. Okay. Okay. And then times with the velocity. So its first velocity, you can see, no, we need the final velocity. Final velocity is smaller. Final speed is smaller because it is slowing down. So you will write 42 minus the mass again. Or you can also do it in this way. V minus Q. Okay, not initial. You can also do it this way. 750,000 times 84. Okay, so now when you calculate it, you will get the answer as 3.2 times 10 raised to the power of 7 Newton second. This is the answer, right? Now, they say calculate the average. The second question says calculate the average force. Again, if we do this equation, we have the mass, but we don't have the acceleration. So why to go to this? We are not going to use this. We can use the simple one because we already have everything. Change in momentum divided by change in time. So change in time is already given. We already know change in momentum is basically the impulse. As I told you, don't be confused. This is basically the same. So when you write this equation, you get 1 mark. Then put the values. The impulse is 3.2 times with times 10 raised to the power of 7 and divided by, I think the time was 80 seconds. Yes, it is here. So divided by 80 seconds. So you will get the answer as 3.9 times 10 raised to the power of 5 newtons. Okay, so this is going to be the force. Okay, there is one question suggests how the shape of the train helps it to travel at a higher speed. This is a very easy question because it's an aerodynamic structure. And if it is an aerodynamic structure, it is streamlined, so it will reduce the drag force, it will reduce the air resistance. You can write anything, okay? And that's why the train will experience less uh, air resistance, so it will actually help it to travel with a high speed. Okay, so that's in it about the momentum. So we are done with these three things, these three. Number one, number two, and number four. Number three, we will do in the next lesson, right? Okay, I can share this slowly with you. We started from here, okay? Then we did these. You can take screenshots of these because screenshots always help. Okay, this was about the positive and the negative concept, you must know. This was about the change impose relation with the momentum. Okay, this was the impose individual equation as force times time, its units. And this was a simple question about the impulse and momentum. I told you take them same. This was the relation we get F equals to delta P divided by delta T from the Newton's second law. Okay, this was the concept about the relation of the time of contact and the effect of force. Okay, that's it. Here was the question, right? Thank you. It was my last, my first lesson. Please give me a proper feedback what I need to improve. It will really help me. Thank you so much.